The synthesis and breakdown of glycogen are called glycogenesis and glycogenolysis. Glycogenesis and glycogenolysis both takes place in most of the the majority of the glycogenesis and glycogenolysis takes place in either of these two tissues like liver and kidneys, muscle. Small amount of glycogen metabolism takes place in kidneys, that is for fueling the local energy need, but majority takes place in liver and skeletal muscle. Among them, the liver glycogen is called is used for maintaining the blood glucose level between 2 meals, whereas the muscle glycogen is called selfish glycogen, which do not contribute to the blood glucose level. Right? What are the other differences between liver and muscle glycogen? The liver glycogen requires a specialized protein called glycogenin to kickstart the synthesis of glycogen, whereas muscle glycogen does not require such kind of protein for initiating the synthesis. Anything else? Glycogenolysis pathway in muscle does not contain glucose 6-phosphatase enzyme. Glycogen breakdown pathway in liver is specialized for having glucose 6-phosphatase. Anything else? See, when you stain under microscope, the glycogen molecules look like this. The first step of glycogen synthesis, this is breakdown, you start with breakdown, fine. Breakdown also you can start. So the molecule is prepared like this and it is broken down from non-reducing ends, one sugar unit at a time. Correct? One sugar unit, one sugar unit, one sugar unit. From here, one at a time sugar units will be released. The name of the enzyme is? The name of the enzyme is a little bit, see, I tell you, the name of the enzyme is only phosphorylase. But our habit is like the name should have two parts, like fructose 6-phosphatase. So it should be something then phosphorylase. The name of the enzyme is actually phosphorylase. But since it is participating in glycogen breakdown, in some books prefer writing glycogen phosphorylase. Okay? But actual name is phosphorylase. Whenever I say phosphorylase, that means it is glycogen breakdown. Okay? What does it require? One inorganic phosphate is required and one glucose 1-phosphate is released. Now problem is when you release glucose as glucose 1-phosphate, it cannot be metabolized in other pathways which utilize glucose for glycolysis, because glycolysis starts with glucose 6-phosphate. HMP shunt pathway starts with glucose 6-phosphate. Correct? So glucose 6-phosphate should be produced from glucose 1-phosphate. That's why liver and muscle has got phosphoglucomutase kind of enzyme. Phosphoglucomutase. So next enzyme is phosphoglucomutase. This glucose 1-phosphate is converted to glucose 6-phosphate by this mechanism. Now this is a reversible step. When we require more glucose 6-phosphate, then it moves rightwardly. When you do not require, it moves leftward, left side. So it does not produce glucose 6-phosphate unless glucose 6-phosphate is utilized in further metabolic pathways. Now the problem is the phosphorylase can cleave alpha-1,4 glycosidic linkages only to within 4 residues from a branch point. Now this is a branch of glycogen. See, this is a glucose molecule which is having branch point. So from this phosphorylase cannot go beyond 4 residues away from the branch point. It is like a shark mouth. It cannot go because of the elongated nose. The shark cannot move till certain distance. Suppose this is the branch point, so it cannot go beyond that. See, now it cannot cleave. If the branch point is like this, then it can go and cleave this. But branch point is here, it cannot go more than 4 residues away from the branch point. And due to this restriction, we require the next set of enzymes. The next set of enzymes duty is to remove the branch point and transfer the residues of glucose from one branch to another branch. Correct? So, they have to remove the branch point and they have to transfer these from that side. 2 functions. So, there are 2 activities, 2 enzymes are required, but both the enzymes are found to act together under one umbrella, and together they are called debranching enzyme. So, debranching enzyme has got 2 enzymatic property. One is alpha 1,4 glucan transferase activity, another is alpha 1,6 glucosidase activity. So, alpha 1,4 activity, 1,4 glucan transferase activity and 1,6 glucosidase activity. Due to these 2 activities, they transfer this pink color part to this black color part. This blue color part are removed singly as glucose 1-phosphate. But beyond 4 units away from branch point, glucose phosphorylase enzyme stops, stumbles. It cannot go further. Then these 3 pink colored dots, glucose units, are transferred to this black colored branch via debranching enzyme by alpha 1,4 glucan transferase activity. This is alpha 1,4, this is also alpha 1,4. So, same branch first, they transfer the chain from one branch to another branch, and due to alpha 1,6 glucosidase activity, this green color glucose is released as free glucose. No more glucose 1-phosphate or 6-phosphate, but free glucose. Now, this step is unique for both liver as well as skeletal muscle. So, if I say that skeletal muscle cannot produce free glucose at all, then it is incorrect, because this step is a proof that skeletal muscle can produce small amount of free glucose, correct, which can be released from muscle to the bloodstream. But how small it is? How often you may expect a branch point in molecule? If you can recall from the small group discussion classes, I have told the highest frequency of glycogen branching. Anyone? At the most, maximally, it can go, branching may take place at every 8 residue of glucose, maximally. 8 residues of glucose, maximally. This maximum is 8, means minimum means it could be 16, it could be 18, it could be 24, it could be 104, right? So, 1 in 8, maximally, 1 in 8, glucose will be released as free glucose in muscle glycogen breakdown. That is too less to be counted as contribution to the blood glucose level. That is why this, although this thing is there, in spite of having this contribution, muscle glycogen is called selfish glycogen. Am I clear? So, the debranching enzymes action has been shown in this figure. You need to draw the figures to explain the enzymatic reactions here. You need to draw these figures. Must. You must be very acquainted with the figures. If you do not understand these reactions by figures, it is very difficult to represent or reproduce in examination unless you are given open book examination. Last enzyme is glucose 6-phosphatase. It is found mainly in liver. See, glycogen broken down to glucose 1-phosphate, convert to glucose 6-phosphate. From here, it goes to glucose plus free phosphate. Now, it can either go to glycolytic pathway or it can go to other pathways which utilize glucose 6-phosphate. Now, this free glucose is produced by glucose 6-phosphatase. Glucose 6-phosphatase. And this enzyme is predominantly present in liver. It is absent in muscle. So, glycogenolysis, stepwise if you see, the first enzyme is phosphorylase, which require inorganic phosphate and PLP, pyridoxal phosphatase coenzyme, which produces glucose 1-phosphate from glycogen molecule. Means glycogen is equal to n number of glucose units. It produces n minus 1 units of glycogen plus 1 glucose 1-phosphate. Now, this glucose 1-phosphate is converted to glucose 6-phosphate by PGM, phosphoglucomutase, which requires magnesium, and the enzyme itself has got an inbuilt phosphate, which is transferred to the glucose 6-phosphate, 6th position of the glucose, and the 1 position phosphate is taken up by the enzyme, and enzyme is regenerated. Every step, first time you read, you know something. Second time you read, you learn something more. Third time you read, you learn something further. You must increase your knowledge step by step. To remember any metabolic pathway, the first thing you require is to know, remember, memorize these steps. Once you remember the steps, then you go for remembering the enzymes, then you go for remembering the additional associated substances required for these steps, then you remember the inhibition, dose, etc., etc. Step by step, if you remember, it will be very easy. If you just see the whole pathway at a glance as a whole, then it will be devastating. Sometimes the pathway is very big, but it looks very small because we have studied it so many times. Like say for example, glycolysis. It has got 10 steps, 11 steps maximum, right? Does it look very big? No, huh? But you see the nucleotide metabolism, the synthesis, biosynthesis of nucleic acid, nucleotide, has also got 11 steps. Do you have any idea about that? No. So when you read that, it becomes very difficult to remember. Why? Because you are reading it for the first time after coming here. Correct? So it is, if it is known to you, it is always easier. So how to make it known? Read more, spend more time with books. That's all. Spend more time with books. That's all. Nothing else. Apply Fevicol on the bench and sit there. The simplest way to study is to apply Fevicol on the bench and sit there. That's all. Rest you will know how to do. But first thing is you have to initiate that motivation that I have to do it. I cannot rely on others who will allow me to copy in the examination, who will allow me to copy in the practical, who will allow me to know the questions beforehand, then only I will pass with good marks. If that someone never turns up, then we will fail again and again and again. But you will never fail if you try from your side. And things may change anytime. Things may change totally, anytime, without any intimation. There is no hard and fast rule that every year season will change in similar way. So don't remain under such misconception. My duty is to make you aware. It's up to you. So glycogen breakdown is done in this process. Remember to mention the difference between liver and muscle glycogen. Then we go to next one, glycogen synthesis. Now in the glycogen synthesis, the first thing you must know that the glucose molecule cannot go and join with each other. Glucose molecule cannot go and join in with each other. See, this is a reaction of polymerization. Can you give example of any other polymerization? At least one example I thought anyone will give. This is nothing but polymerization. Can you give any example? Come on, quickly. Don't waste time. How protein is formed? Peptide synthesis, protein synthesis. Is it a polymerization? Yes. So how peptide is formed? By amino acids are joined along with amino acid tRNA. The tRNA carries the amino acid. In this case, who carries the glucose? UDP. So if you can recall, in last examination, one question was there, function of nucleotides. How many of you have written this one? I found only one or two in whatever copies I corrected. They act as carrier molecules. Like they carry sugar units, glucose units in the synthesis of glycogen, UDP-glucose. They carry glucuronic acid in the synthesis of heparin, mucopolysaccharides, UDP-glucuronic acid. Correct? They carry choline in the synthesis of phospholipids, CDP choline, for phosphorylyl choline's biosynthesis. Correct? So they act as carrier molecule in biosynthesis. So here the first step is formation of carrier molecule. Glucose 1-phosphate plus UTP. Now UTP itself is a high energy compound. UTP itself is a high energy compound. First thing is UTP being itself a high energy compound, it does not require ATP to provide energy. And this breakdown of the gamma phosphate provides this phosphate. Breakdown of the gamma phosphate provides the energy, enough energy. Sorry, not in this phosphate. This beta and gamma are removed. Usually ATP, we have seen that in case of ATP, donating phosphate to glucose, in glucose 6-phosphate reaction, the gamma phosphate is released. Here, the breaking takes place here after alpha phosphate. Okay, and both beta and gamma phosphate are removed in the form of PPI. Correct? And this 1-phosphate with glucose 1-phosphate is attached with the group phosphate of first or alpha phosphate of the uridine to form this UDP-glucose. So 1-phosphate from glucose, 1-phosphate from UTP. They form UDP-glucose. And this PPI, what is function as PPI? PPI function as a battery, energy provider. In the next step or coupled step, it is broken into 2PI. And that energy, how much energy? 7.2 kilocalorie per mole. That much energy is released, and that is sufficient to convert glucose 1-phosphate to UDP-glucose. Now UDP-glucose is ready for carrying glucose units. Achha. Now this glycogen part, take a few notes if you want. In your book it is given something more also, the molecular weight, number of amino acids present in glycogen, but overall you must remember their function. It is active when it is in dimeric form. It has got a specific tyrosine residue in the active site which carries the glucose molecule or attaches with the glucose molecule. Okay, so at least this much it is active in dimeric form, and it carries a tyrosine residue in the active site which binds with the glucose molecule. The growing chain, this much you remember. The initial few glucose molecules are attached to this glycogenin non-enzymatically. Glycogenin plus initial 3 or 4 glucose units together, they are called glycogen primer. This glycogen primer is synthesized by adding 3 to 4 glucose units to the glycogenin protein non-enzymatically. No enzymes are required. Either actually no enzymes are there, or maybe it is not discovered yet, I don't know. Till it's discovered, no enzymes, non-enzymatic steps. Fine. Next addition, further addition of glucose require glycogen synthase enzyme. but initial 3,4 does not require glycogen synthesis. And this glycogen primer is foremost necessity for synthesis of glycogen in liver, not in muscle. In liver, not in muscle. Glucose goes on adding one glucose unit at a time to the glycogen primer with the help of glycogen synthase enzyme. With the help of glycogen synthase enzyme. Fine. How far it will synthesize? It will synthesize say around 10 to 12 units of glucose at a stage, but then it will stop because the chain is becoming very long. Then a branching enzyme will come which will introduce branch point in the glycogen molecule, and branching enzyme will transfer a part of the growing glycogen chain, to its neighboring glycogen chain. See, count how many are there. It is around 6 glucose residues are transferred from the terminal end of one glycogen chain to the next. Okay, see, around 6. Let's count it as 7, but it should be 6 actually. 6 molecules of glucose units are transferred to this one, where at least 4 residues away from the branch point. This is branch point 1, 2, 3, 4. See, this is the 5th one. So at least 4 residues away from the branch point, it will transfer the growing chain of the glycogen. So now we have, see, previously we had 1 and 2 points to continue synthesis of glycogen. Now we have 1, 2 and 3 points to continue synthesis of glycogen. If it goes further, then it will be again 3 will be divided in 6 branch points. So it will have more branch like that. It will go on continue adding branch point as long as possible. How long? As long as blood glucose level is pretty high and liver is flooded with glucose. The moment, say after 4 hours, after 3 hours or 4 hours, the blood glucose level tends to come down, it will stop. Then the reverse process will start, glycogen breakdown. Okay? It is like a switch. You switch on the fan, you lose the money. You switch off the fan, you start saving. So glycogen synthesis and breakdown, they work like a switch on off. When you switch on the synthesis, the breakdown will switch off. If you switch on breakdown, the synthesis will switch off. Correct? And it is done mostly with the help of hormones. See, at the end it looks like this. These two are glycogen molecule, glycogen primers. So this is one glycogen primer, this is another glycogen primer. 2 glycogen primer, they give rise to this such a big molecule of, okay, same thing. Now, the glycogen is broken down to glucose 1-phosphate. It can go for synthesis of glycogen, it can go further to glucose 6-phosphate to produce glucose, or it can go to glycolysis. Regulation of glycogen metabolism. This is very, very important and favorite question for examiners. Regulation of glycogen metabolisms. The main enzymes which we will discuss for regulation of synthesis is glycogen synthase, and regulation of breakdown is phosphorylase, or popularly known as glycogen phosphorylase. Now, these are the factors which affect the glycogen synthase and phosphorylase. Write down and remember first. AMP activates phosphorylase. Why? AMP why activates? What is the reason behind? The mechanism is what? Allosteric mechanism. But reason behind is phosphorylase activated means when? When you need more energy, glycogen is broken down. Correct? That means AMP, ATP is less, AMP is more. So when AMP is more in the system, it will trigger activity of phosphorylase. ATP and glucose 6-phosphate will inhibit, just opposite. Because glycogen breakdown is inhibited when ATP and glucose 6-phosphate are plentiful. Means when you are taking food, the huge amount of glucose is rushing into the hepatocyte. By glucokinase it is converted to glucose 6-phosphate. So more and more glucose 6-phosphate is present, less it will go for glycogen breakdown. It will inhibit further production of glucose 6-phosphate by breaking down glycogen. So product inhibition. Glycogen synthase, it is activated by glucose 6-phosphate, just opposite. Glucose 6-phosphate, see, it inhibits phosphorylase and it activates synthase. Because glucose 6-phosphate is more, so now excess of glucose can be stored. Regulation by hormones, at least you should remember these points. Inhibit glycogen synthesis, glucagon and epinephrine. Glucagon and epinephrine are hyperglycemic hormones. There is only one hyperglycemic hormone in our body, that is insulin. Rest all are hyperglycemic. So glucagon and epinephrine both, they inhibit glycogen synthesis, they activate glycogen breakdown, they increase glycogen catabolism, increase blood glucose level in fasting or starvation state. Insulin, whereas it does exactly opposite what glucagon does. It may not be exactly opposite to what epinephrine does, but it is always exactly opposite to what glucagon does. You always remember, insulin and glucagon, they are just exactly opposite in metabolic function. There is no other two hormone set of hormones are there which actions are exactly opposite to each other. So for example, epinephrine or norepinephrine, both are hyperglycemic. Right? So inhibit glycogen phosphorylase, activate glycogen synthase, and increase glycogen synthesis and decrease blood glucose level. So they decrease, insulin decrease blood glucose level by increasing the utilization of glucose by tissue. Right? Utilization of glucose by tissue, remember. Now, can we remember this pathway? Yes, everyone remember. Every year, every student have remembered it, written in the examination. So you can also remember. It's very easy. Okay. So this cascade pathway shows the covalent modification of different enzymes in the regulation of synthase, glycogen synthase or phosphorylase. So it starts with epinephrine above, correct? Glucagon or epinephrine. They first bind to a specific receptor, beta receptor, and which triggers the activation of one enzyme called adenylate cyclase. The adenylate cyclase, the adenylate cyclase when it is active, it converts ATP to cyclic AMP. ATP to cyclic AMP. Now cyclic AMP is again converted back to AMP by phosphodiesterase. Remember, phosphodiesterase. That means it is a dephosphorylation phosphate breaking. Correct? There is an inhibitor called inhibitor 1-phosphate which inhibits this one, this particular step, and which is triggered by insulin. Fine. Now this cyclic AMP then activates another protein kinase called CDPK, cyclic AMP dependent protein kinase. How? By phosphorylating it. So each time here glucagon causes generalized phosphorylation, insulin causes generalized dephosphorylation. So glucagon phosphorylates, triggers cyclic AMP production, cyclic AMP triggers CDPK, cyclic AMP dependent protein kinase, which triggers phosphorylation of glycogen synthase, phosphorylase kinase. Phosphorylase kinase, when it is active, it is phosphorylated. When it is inactive, it is dephosphorylated. When it is active, it is termed as phosphorylase A. When it is inactive, it is termed as phosphorylase B. Correct? So active phosphorylase kinase and phosphorylase enzyme. Phosphorylase is converted from B to A. A to B are converted by, see, both phosphorylase kinase A to B, phosphorylase A to B both are converted by phosphodiesterase, phosphatase enzyme, so which require water. Right? All these phosphatase steps are actually stimulated by insulin. Glucagon stimulates phosphorylation, phosphatase stimulated by insulin. Correct? Now, active phosphorylase kinase will activate phosphorylase. Active phosphorylase will break down glucose, glycogen to glucose. The glucose is produced. See, this phosphorylase, active phosphorylase will activate, will cleave glycogen to glucose molecule. So, like this is called covalent modification or hormonal regulation of glycogen breakdown. So, can we repeat? If it is not done here, it will never be done outside the class. Can we repeat? First one is, the hormonal trigger is glucagon or epinephrine. Receptor for glucagon epinephrine is beta receptor. Right? Next is, it triggers the activation of one internal enzyme called arenylase cyclase. Activated arenylase cyclase will synthesize cyclic AMP from ATP. Activated cyclic AMP or increasing concentration of cyclic AMP will trigger activity of CDPK, cyclic AMP dependent protein kinase. Active CDPK will convert phosphorylase kinase B to phosphorylase kinase A by phosphorylation. Phosphorylase kinase A then will activate phosphorylase enzyme by phosphorylation. In both the steps, it will require inorganic phosphate. Phosphorylation is taking place. So, it will phosphorylate and to produce active phosphorylase enzyme. Active phosphorylase then will cleave glycogen molecule to glucose molecules. Clear? So, whenever we need more glucose in the blood, our cell, inside the cell, cyclic AMP concentration increases. Remember, this is the key point. If I ask you what is the key point in this whole diagram, in case of, under the effect of hyperglycemic hormone, always remember cyclic AMP concentration will increase. This is the most important point. This is such an important point that this point is maintained even in prokaryotes. We are eukaryotes, right? This point is maintained even in prokaryotes which do not have anything called hormone. So these are the key genetic points which says like once upon a time they were our ancestors. Fine? Genetic tracing points. For those who cannot remember such a big one, for those who cannot remember the previous slide, easier one is here. Fine? Just have a look, quick look, then we will move on to the next slide. See, you can't expect me to read from this slide. That is the last possible thing I will do in my life. I cannot read from slide. Reading is your job. Explaining is my job. Right? Any question? Any doubt? Now, this is the opposite. Glycogenesis, synthesis, how it is regulated. It is much simpler. Again, it starts with, see, glucagon and epinephrine. It triggers beta receptor. It triggers activation of arenylase cyclase. Arenylase cyclase, active arenylase cyclase will trigger synthesis of cyclic AMP. Cyclic AMP will stimulate CDPK. Same thing. CDPK. Now this CDPK has got different function in glycogen breakdown and glycogen synthesis. In breakdown process, it will trigger, it will phosphorylate and activate those enzymes which will prefer breakdown process. And here also it will phosphorylate, but the enzymes related to synthesis process becomes or rendered inactive by phosphorylation. Understood? No. See, I give you one example. There are two employees in the house. One employee's salary is 200 rupees, another employee's salary is 20,000 rupees. Correct? Now you give 500 rupees to each one of them. 500 rupees means consider it like a phosphorylation. So the person whose salary is 200 rupees, he will do whatever he want. Will be the same in case of whose salary is to 20,000 rupees. You damn care. Similarly, when phosphorylation takes place in phosphorylase kinase, it is active. When phosphorylation takes place in synthase, it is inactive. It is inactive. The same system, one will be off, another will be on. When glucagon is there, that means low glucose but low blood glucose. So glucagon will trigger cyclic AMP production. Cyclic AMP production will trigger CDPK activation. CDPK will trigger phosphorylation of certain internal enzymes. When it phosphorylates glycogen synthase, in muscle there is another enzyme called GSK, which is actually GSK, glycogen synthase kinase, which can further be activated by free calcium ion in muscle. And that is a separate question. At least if you remember this one, you will get good marks and you will pass happily. These things are not so easy like I am showing. Much complicated, different tissue have different implementation, different ways of regulation of pathways, but we confine our discussion to a very small region which can be digested by you at this level. Because if you cannot digest, you cannot reproduce properly. It will mix up, the vomiting will not be good. So this one will trigger the inactivation of glycogen synthase. So glycogen synthesis will stop. Correct? Protein phosphatase 1 is an enzyme which is inhibited by inhibitor 1-phosphate. An inhibitor which inhibits protein phosphatase 1 is termed as inhibitor 1-phosphate. Can we repeat? Dephosphorylation takes up by protein phosphatase 1. Protein phosphatase 1 is inhibited by a compound called inhibitor 1-phosphate. Production of inhibitor 1-phosphate is dependent on insulin. Nowhere it is written in this here, not even in your book. Production of inhibitor 1-phosphate, sometimes they may ask. So production of inhibitor, how insulin acts. Instead of asking how glucagon does it, they might ask you how insulin does it. What will do? You have to write, answer is same. You have to write the same pathway with glucagon. Point out where there is dephosphorylation step. Those dephosphorylation steps of kinases enzymes are triggered by protein phosphatase 1. Protein phosphatase 1 is inhibited by inhibitor 1-phosphate, produced by or stimulated by production of inhibitor 1-phosphate is triggered by insulin. Now, can we remember this chart? Definitely we have to remember. Everyone remembers. Any Tom, Dick and Harry in medical course will remember all this. Because ultimately you are going to treat diseases, you are not going to measure glycogen. Are we? No. So why should you be so reluctant to diseases? Diseases you have to remember. Now these are the diseases called glycogen storage disorder, GSD. The glycogen storage disorders are of several types. How many types have been given here? 7. There are 9 types or 12 types till date. Okay? I'll be happy if you write 7 times. I'll be satisfied if you write at least 5 types. Now is okay? Huh? So, can we remember like this? What you have to remember? We have to remember the type 1, 2, 3, 4, 5, 6, 7. We have to remember the defective enzyme. We have to remember the organ affected. We have to remember the clinical features. Correct? This part is optional. Optional for you. 1, 2, 3, 4, 5. 5 here, 7 rows. 5 rows, 5 columns and 7 rows. Fine. Now, everything is given in every book. I am not going to tell you anything new. What I am going to tell which are important, number 1, and how to remember this chart. Are you interested? Then I will go through. Otherwise, I will just skip it. Is there anyone who is interested to know how to remember this chart? Fine. Can we remember like this? VP, CAM, HT, VIP camera, Hindustan Times, whatever it is. VP, CAM, HT. V stands for von Grass disease. P stands for Pompe's disease. C stands for Cory's disease. A stands for Andersen's disease. Sen. Not Bengali. Switzerland, Swiss fellow. Switzerland is full of sense. You see the Switzerland football team, full of sense. So Andersen's, then CAM. M stands for McArdle's. H stands for Haar's disease. But Haar is not affected, only him is affected. T for Taruy's disease. So von Grass, Pompe's, Cory's, Andersen, McArdle's, Haar's, Taruy's disease. Tarui, T-A-R-U-I, Taruy's disease. Von Grass disease, Pompe's disease. Fine. Now the enzymes related to that. First one is glucose 6-phosphatase. Second one is acid maltase. Just write this name. First one is glucose 6-phosphatase. Second one is acid maltase. Third one, C. First debranching enzyme. Fourth one, then branching enzyme. M stands for muscle phosphorylase. M for muscle phosphorylase. H for liver phosphorylase. T for muscle phosphorylase kinase. So what I did, I just displayed my strength of memory, right? Why? Just to inspire you so that you can also do the same. So I don't know how many of you have been inspired. If few of you also are inspired, then my job will be done. Otherwise, like adding Fevicol and reading hours together, that path is already there, always there. So, can we repeat the enzymes? Can we repeat the enzymes? First one is glucose 6-phosphatase, second one is acid maltase, third one is debranching enzyme, fourth one is branching enzyme, fifth one is McArdle's disease, muscle phosphorylase, sixth one is liver phosphorylase, and last seventh one is muscle phosphorylase kinase. Eighth one is actually liver phosphorylase kinase, which is not mentioned. Not required. Trust me. If you write 7, very good. If you write 9, good. Why? Because 8, 9, many of the teachers don't know. Fine? So it doesn't matter. Beyond the, when you are hitting a 6, if you hit 2 meters more than the boundary, and if you hit 100 meters more than the boundary, will you get any extra marks? Still your score will be 6. When you hit 6, like that. So you should know the boundaries. Beyond that you can jump, but it will not carry any extra credit. Now the enzymes is done. Now which organs or which clinical features are there, we will discuss in next class.
This is the dorsal root of the now. How to say it must know I use the term root in two different names. Here are the roots of the nerve. Here the fine fibers, fine thread, super motor. Area is spinal cord that we call roots of the nerve. Roots of the nerve. What better term? It is a very small because it is flex. And you will see liver is a liver. A small liver can regulate. Similarly, dorsal nucleus or posterior lamina and a ventral part. We call ventral lamina. This is the dorsal lamina of the spinal nerve. Name suppose 7 cervical nerve. We call dorsal ventral lamina of C7 or 7 cervical nerve. And ventral lemmas usually supply the anterolateral part of the body and dorsal lemma supply the posterior part of the body. We are not concerned about the dorsal lemma. We are only concerned about the ventral lemmas. These ventral lemmas, so there are spinal nerves. I have already told you there are 31 pairs of spinal nerves. What will say? 31 pairs. Can be right side, left side. 31 pairs. কিভাবে নাম হবে? সার্ভাইকাল রিজন 8 কিভাবে নাম দিয়ে আমরা C1 C2 C3 C4 in this way C8 cervical 1 spinal nerve cervical 2 similarly thoracic region 12 lumbar region 5 sacral region 5 proximal 1. So ultimately there are 31 pair of spinal nerve. Now in certain situation the ventral lemmas of the spinal nerve join to form a network. We call it plexus. Similarly, in this region, neck and upper part of the thorax, we call it brachial plexus. There is a plexus formation in lower part of the neck and upper part of the thorax. We call it brachial plexus. We call brachial plexus. এইবারে হচ্ছে look, how do we read this plexus? Whether it is a brachial, whether it is a lumbar, how do we read? First formation, next branches, next clinical application. In these 3 columns we will read. So these are the spinal nerves. These are the spinal nerves. These are the lobes. These are the spinal nerve coming out to the vertebral foramen. These are the rootlets, ventral rootlets, and dorsal rootlets joining from the spinal nerve. In the dorsal rootlet, there is a ganglion swelling. We call dorsal ganglion. Not only the spinal nerve carrying the motor or sensory fiber doing the action and sensory fibers carrying the sensation. It also carries, this spinal nerve also carries sympathetic and parasympathetic fibers. So the spinal nerve supply not only carries motor fibers which part, that's in the fibers which goes to the muscle and order them to do something. What is sensory fiber? There is a sensation, whether it is a pain, whether it is a temperature, whatever it may be, it carries the sensation to the brain so that we can know that what type of sensation. Plus, it also carries some, which is not red, is black, the sympathetic fiber and parasympathetic fiber, we call autonomic fibers.
এই কথাটা প্লিজ ডোন্ট মিস ভেন্ট্রাল রামাই formed by the C5-C8 nerve. No. Ventral rami of the cervical 5 and cervical 8. এটা আরেকটা ভুল হয়েছে এখানে আমার লেখা স্পাইনাল নার্ভস লেখাটা উচিত ছিল স্পাইনাল নার্ভস ভুল মানে more specific, brachial plexus is a nerve plexus that is derived from the ventral primary rami of the lower 4 cervical nerves and first thoracic spinal nerves, C5 to C8 and first thoracic spinal nerve, and situated partly in the root of the neck and partly in the axilla. That I have already told you. Brachial plexus is a nerve plexus. Definition guli eram bhabe likhbe. What is asked? First ওই লাইনটা লিখবে brachial plexus. What is brachial plexus? Sir, brachial plexus is a nerve plexus. Plexus arterial plexus হতে পারে, venous plexus হতে পারে. So better to say it is a nerve plexus that is formed by the ventral primary rami of the C5 মানে cervical 5, C6, C7, C8 and T1 spinal nerves and is situated partly in the lower part of the neck and partly in the axilla.
Roots of the spinal nerve. These are the different things. Roots of the spinal nerves that's been coming immediately from the spinal cord, from the spinal nerves. তাকে বলা হচ্ছে রুট। এটার সাথে এটা দিয়ে ফেলবে না। These are the roots. These are the not root of the brachial plexus. These are the roots of the spinal nerve, right? These are the roots of the spinal nerve. And here, what we call is the root or roots of the brachial plexus. So don't misunderstand the brachial plexus. Roots of the spinal nerve means those roots are coming
Immediately from the spinal cord. And root of the brachial plexus means ventral primary rami. Ventral primary rami. Sutrang, don't overlap these two. They are totally different. So these are called root of the brachial plexus. Root of the brachial plexus. So these are the roots. Now, so we write roots. Now it will form plexus by joining. So it has been found the C5 root of the brachial plexus join with the C6 to form a trunk. C7 is totally selfish. They don't want to join with any other root. So it goes straight. And C8 and T1 join to form another trunk. So these are called the trunk. So we call it, it is situated upper, it is situated the middle, it is situated in the lower region. So we call the upper trunk. This is the middle trunk. This is the lower trunk. So upper trunk is formed by, bolo, hey, তুমি বলো, upper trunk is formed by, এদিকে তাকাও, ওদিকে তাকিয়ে ধরতে পারবে না। জয়নিং অফ, কার কার জয়েন করছে? C5 and C6. Middle trunk, C7, totally. Lower trunk, C8 and T1. Right? Now, after formation of the trunk, they immediately divide into a posterior or anterior, better to say a anterior division and a posterior division, or a dorsal division or a ventral division. Better anterior division and posterior division. So it divides into anterior division and a posterior division. And a posterior division. আমি এখানে posterior ডিভিশনটা ওপরে আঁকলাম, এটা ভালো করে লক্ষ্য রাখো, আমি ইচ্ছে করে ওপরে রাখলাম টু হ্যাভ টু সো দ্যাট ফর ড্রয়িং রিজন অনলি, আদারওয়াইজ ইউ শুড বি লো, বাট আমি ইচ্ছে করে ওপরে রাখলাম। নাও all the posterior division of the upper, middle and lower trunk join to form, এটা হচ্ছে ডিভিশন। Cord of the brachial plexus, posterior cord, and anterior division of the upper and middle trunk join to form the lateral cord of the brachial plexus, and posterior lower trunk continued as the medial cord of the brachial plexus. তাহলে কি হলো, আবার নিজেরা রিক্যাপিচুলেট করো। C5 and C6 root join to form the upper trunk. C7 root continued as a middle trunk. C8 and T1 root join to form the lower trunk. So there are three trunks: upper trunk, middle trunk, and a lower trunk. Trunk after formation divides into anterior division, and a posterior division. এটা posterior, এটা গ্রিন দিয়ে রাখা উচিত ছিল। তাহলে কি হলো, upper trunk divides into anterior division, middle trunk divides anterior and posterior division, middle trunk divides into anterior and posterior division, lower trunk divides into anterior and posterior division. এখানে স্পেশালি আমি anteriorটা লোয়ার রেখেছি, আদারওয়াইজ ভালো বোঝা যেত না। All the posterior division of the upper, middle and lower trunk join to form a large trunk known as the posterior cord of the brachial plexus. All the posterior division of all the trunks join together to form the posterior cord of the brachial plexus. Upper anterior division of the upper and middle trunk join to form the lateral cord of the brachial plexus. And anterior division of the lower trunk again self is continued as the medial cord of the brachial plexus. এবারে আমরা ছবি দেখব। তাহলে ফরমেশনে কি কি হচ্ছে, brachial plexus is formed by root trunk division cord, RTDC, RTDC, root trunk division cord, root trunk division cord, RTDC. এই দেখো, so this is the roots C5
continued as the medial cord of the brachial plexus. তাহলে এটা অসুবিধা এরকম ভাবে দেখুন, এবারে ভালোভাবে দেখুন। C5, C6, C7, C8, T1 root join together to form the upper or superior trunk. C7 continued as the middle trunk. C8 and T1 join together from the lower or inferior trunk. বুঝতে পারছো? ক্লিয়ার হচ্ছে তো? যে ট্রান্সফরমেশন করলো they divide into anterior division red and a posterior division green. Anterior division red and posterior division green. They form the trunk. So divides into anterior lateral. So anterior division divides into divides into sorry. So it divides into anterior division and division of the lateral cord and a posterior cord and a medial cord. How this medial cord is formed? We divide into अभी हम medial cord पे आए. Divide into देखा. अभी हम medial cord पे आए. এবারে অনেকে এরকম ভাবে আঁকা ডিফিকাল্ট হবে পরীক্ষা, তাহলে কিভাবে আঁকতে পারেন? স্কিমেটিক ডায়াগ্রাম। স্কিমেটিক ডায়াগ্রাম কি? C5 straight line, C6, C7, C8, T1, C5, C6, C7, C8, T1, C5 and C6 join together to form C7 continue, C8, T1 continue. তাহলে এটা কি হলো? What is it? Roots. এটা কি? Trunk. এটা কি trunk? Upper trunk.
এটা middle trunk, এটা lower trunk. Upper trunk is formed by joining of the C5 and C6 roots. C7 is a continuation of the C7 root. A middle trunk is a continuation of the C7 root, and lower trunk is formed by the C8 and T1 root. Then it divides into two division. Anterior division, anterior division, anterior division. Posterior division, posterior division, posterior division. So all the posterior division join together to form the posterior cord. Anterior division of the upper trunk joined to the lateral cord, and this continued as the posterior cord. So this is the lateral, posterior is the medial. Cord, cord, cord. Anterior division, anterior division, anterior division.
This is the posterior division. I mean, posterior division, posterior division. This is the upper cord. Middle cord. Lower cord. Upper trunk. These are the roots.
সুতরাং ব্রেকিয়াল প্লেক্সাস ফর্মেশন আশা করি তোমরা বুঝতে পেরেছো যে রুট ট্রাঙ্ক ডিভিশন কর্ড কিভাবে হয়। নাও What are the situation? It is the lower part of the neck and in the axilla. কোনটা lower part of নেকে থাকে, কোনটা axilla থাকে? The roots and the cords, roots and the trunks are situated in the lower part of the neck, in the posterior triangle of the neck. When you will read the neck, you will learn that in the neck there are anterior triangle and a posterior triangle. So roots and trunks are situated in the posterior triangle of the neck region. So এখন আমরা পড়ছি না এগুলি, কারণ বুঝতে পারবে না। And division কোথায় থাকে? Just behind the clavicle, posterior to the clavicle. That's mean in the cervico-axillary canal or mean the apex of the axilla. And cords are situated in the axilla. You have seen in your dissection in the axilla. And it is related to the axillary artery. So roots and trunks are situated in the lower part of the neck, in the posterior triangle. Division situated in the apex of the axilla, behind the clavicle. And cords are situated in the axilla in relation to the axillary vein and axillary artery. আচ্ছা, এটা আমি পরে আসবো। The roots are situated in the posterior triangle between scalenus anterior and scalenus medius muscle. Just দুটো মাসেলের মধ্যে থাকে। Trunk. Roots of C5 and C6 join to form upper trunk. Roots of C7 continued as a middle trunk. Lower trunk, roots of C8 and T1 join to form lower trunk. Position again in the posterior triangle of the neck. Division. Each trunk divides into a ventral division and dorsal division. Position lie partly in the root of the neck and partly behind the clavicle. Cords. Union of the ventral division of the upper and middle trunks. বলেছি। Medial cord, ventral division of the lower trunk only. So medial cord, সুতরাং medial cord এর root value কত? C8 and T1. Medial cord এ যে fibers, যে branch বেরোবে তার root value হবে C8 and T1. কেমন? Posterior cord, joining of the dorsal division of all the three trunks. The cords are named according to relations of the cords to the second part of the axillary artery. So, relation with the cords in the second part of the axillary artery. So, the cord which is situated lateral to the second part of the axillary artery, we call lateral cord. The cord which is situated medial to the second part of axillary artery, we call medial cord. The cords which are situated posterior to the axillary artery, we call posterior cord. Branches. That is very important, often asked in the oral examination, often asked in the your OSP. What are the branches? Is there any branches from the roots? Yes, there are branches from the roots. Nerve to serratus anterior. You know this is a muscle. এখানে একটা মাসল আছে, তাকে আমরা বলি serratus anterior. This serratus anterior supplied by a nerve which is called the nerve to serratus anterior. This nerve to serratus anterior takes origin from the C5 root, C6 root, C7 root and occasionally C8 root. অনেক সময় C8 root absent থাকে। C5, C6, 7. So from the roots this nerve is formed. C5, C6 and C7 we supply to serratus anterior muscle. What are the next? Phrenic nerve. Phrenic nerve is actually not totally contributed by the brachial plexus. Phrenic nerve is supplied by the C3, C4, C5 nerve. But C5 root coming from the brachial plexus. Next, dorsal scapular nerve or nerve to rhomboidus. তোমরা জানো rhomboidus major minor রয়েছে, and this nerve coming from this C5 and C6 or occasionally C5, and it is called the dorsal scapular nerve. Dorsal scapular nerve. And নেকে কিছু মাসল রয়েছে, longus colli and scalenus, anterior, medius and posterior. These are supplied, these nerve supply coming from the roots of the brachial plexus. So what are the branches from the roots? Nerve to serratus anterior, dorsal scapular nerve, branches to longus colli and scalene muscle, and branches to phrenic nerve. তোমাদের মুখস্থ করে নিতে হবে, এটা উপায় নেই, এটা কোনো মনে রাখার কিছু নেই, you have to memorize it. Nerve to serratus anterior, dorsal scapular nerve, branches to longus colli and scalene muscle, branches to phrenic nerve. Roots এর পরে কি আছে? Trunk. There is a trunk. Only from the upper trunk two nerves arises. No branch coming from the medial cord, middle trunk, no branch coming from the lower trunk of the brachial plexus. Only upper trunk of the brachial plexus gives very important branch, suprascapular nerve and nerve to subclavius. ঠিক এখান থেকে নেয় suprascapular nerve and nerve to subclavius. কেমন? এটা হচ্ছে আপার ট্রাঙ্ক অফ দ্য ব্রেকিয়াল প্লেক্সাস থেকে নেয়। নো ব্রাঞ্চ কামিং ফ্রম দ্য মিডল ট্রাঙ্ক, নো ব্রাঞ্চ কামিং ফ্রম দ্য লোয়ার ট্রাঙ্ক। অনলি আপার ট্রাঙ্ক give rise to suprascapular nerve and nerve to subclavius. Why it is important? আসবো ক্লিনিক্স যখন পড়াবো, because it is the Arps point, ERB double S apostrophe S Arps point, আসবো আমি। Branches from the cords, lateral cord, lateral root of lateral pectoral nerve, musculocutaneous nerve and lateral root of median. From the medial cord, medial pectoral nerve, medial cutaneous nerve of arm, medial cutaneous nerve of forearm and ulnar nerve. From the posterior cord, upper subscapular nerve, lower subscapular nerve, thoracodorsal nerve, তারপরে রয়েছে এই না না posterior cord কি বলছি, medial cord তো বলে দিয়েছি, lateral cord বলিনি না, lateral cord, from the lateral cord, lateral pectoral nerve, বলেছি কি lateral cord, musculocutaneous nerve, বলেছি কি আমি না, দাঁড়া বলি কোনটা বলেছি, ল্যাটারাল কর্ড বাদ চলে গেছে। তাহলে ল্যাটারাল কর্ড থেকে কি কি নিচ্ছে? ল্যাটারাল পেক্টোরাল নার্ভ গেল, ল্যাটারাল পেক্টোরাল নার্ভ, ল্যাটারাল রুট অফ মিডিয়ান নার্ভ, আই উইল এক্সপ্লেইন ইট, ল্যাটারাল রুট অফ মিডিয়ান নার্ভ, আর কি মাস্কুলোকিউটেনিয়াস নার্ভ, মাস্কুলোকিউটেনিয়াস নার্ভ বলেছি মনে হচ্ছে। আর ফ্রম দ্য মিডিয়াল কর্ড, medial pectoral nerve, medial nerve, medial nerve to the medial cutaneous nerve of the arm, medial cutaneous nerve of the forearm and ulnar nerve and medial root of median nerve. এইখানটা আমি একটু এক্সপ্লেন করছি। What is the roots of এই যে medial cord, lateral cord থেকে কি কি নিচ্ছে? Lateral pectoral nerve and musculocutaneous nerve. It gives a branch which is called the medial root of median nerve. So this carries the fibers of the C5 and C6 fibers, and from the medial cord there is another root arise from the medial cord, arises medial pectoral nerve, medial cutaneous nerve of the arm, medial cutaneous nerve of the forearm, and medial root of median nerve. This lateral root and median root join to form the actual median nerve. So median nerve is contributed both by lateral cord and the medial cord. So root value is C5, C6, C8, T1. মনে রাখবে? So immense value. So this is the medial nerve, and also medial cord has got a branch known as the very important branch known as the ulnar nerve. তাহলে medial cord এর branch হলো কি কি? Medial pectoral nerve, medial cutaneous nerve of the arm, medial cutaneous nerve of the forearm, ulnar nerve, and medial root of median. এরপরে এই যে ulnar nerve থেকে একটা ছোট্ট টুইগ চলে যায় মিডিয়াল নার্ভে, which carrying the fibers of the C7. মাথায় গুলিয়ে গেছে এটা। আবার প্রথম ভালো করে শোনো এটা root value of the median nerve. Actual root value is C5, C6, C7, C8, T1 nerve. How it is formed? তাহলে ভালো করে শোনো প্রত্যেকে যারা এখানে রয়েছে, কোনো বইতে এভাবে এক্সপ্লেইন থাকবে না। রুট ভ্যালু অফ দ্য মিডিয়ান নার্ভ ইজ C5, C6, C7, C8 and T1 nerve. How it is formed? It is formed by, from the lateral cord, a branch is given. We call it lateral root of median nerve, carrying fibers C5 and C6, right? কারণ এই দেখো এই C5, C6 নার্ভ এরম করে গিয়ে এরিয়ে আসছে। Similarly, from the medial cord, a branch is given to the from the medial nerve. We call the medial root of median nerve, carrying the fibers C8 and T1. তাহলে C7 টা কোথায় গেল? Yes, এই যে ulnar nerve ফরমেশন করবে, আলটিমেটলি দেখবে আলনার নার্ভেও C7 ফাইবারস আসছে। কোথার থেকে আসছে? পরে আসছি। সো ইট গিভস এ টুইক টু দ্য মিডিয়ান নার্ভ, সো দ্যাট রুট ভ্যালু অফ দ্য মিডিয়ান নার্ভ ইজ C5, C6, C8, T8 নার্ভ। কোথায় গেল? From the posterior cord, upper subscapular, thoracodorsal nerve, lower subscapular nerve, axillary nerve and radial nerve. এবারে দুটো টার্ম অফেন জিজ্ঞেস করে, প্রিফিক্সড ব্রেকিয়াল প্লেক্সাস এন্ড এ পোস্টফিক্সড ব্রেকিয়াল প্লেক্সাস। আমরা ব্রেকিয়াল প্লেক্সাসের কি বলেছিলাম? রুট ভ্যালু কি? C5 to T1। ধরো আমার নেই, ওর নেই, এর নেই, সে নেই, ওর আছে, সেখানে T1 এর কন্ট্রিবিউশনটা ইজ ভেরি লো। T1 এর কন্ট্রিবিউশন ইজ ভেরি লো, বাট another root comes to form the brachial plexus, that is the C4. C4 nerves, right? তাহলে রুট ভ্যালু কি হচ্ছে ব্রেকিয়াল প্লেক্সাসের? C4, C5, C6, C7, C8 and slight T1. And this type of brachial plexus we call prefixed brachial plexus. Where pre means above, where there is an for C4 given a twig. Similarly, what is postfixed brachial plexus? Where the contribution of the C5 is minimum, but T2 gives a contribution to the brachial plexus, and we call post-fixed brachial plexus. So their root value is C5 minimum, C6, C7, C8, T1 and T2. So these are the prefixed and post-fixed type of brachial plexus. About a last, what is Arb's point? What is Arb's point? You know, this is the C5 and C6 root. C5 and C6 root, they join together to form the upper trunk and divides into anterior and posterior division, right? So, and from the upper trunk arises suprascapular and subscapular nerve. তাহলে আমরা এটাকে একটু বড় করে আঁকি। C5, C6 join together to form the upper trunk and divides into anterior and posterior division. Root, upper trunk. And it upper trunk gives rise to two nerves, suprascapular nerve and nerve to subclavius. And this region, যদিও এখানে খুব বড় করে এঁকেছি, but in practice very small region. In literally it is a very small region, right? For schematic diagram I make it large. This region where the upper root of C5, C6 join to form the upper trunk and divides into anterior and posterior division and give rise to suprascapular and nerve to subclavius. So there is act number 1, 2, 3, 4, 5, 8, these nerves all together. This area we called the Arps point, because Dr. Arps first described it. So these are called the Arps point. A Arps point, this area is very much vulnerable to injury, especially during childbirth. When there is a difficult childbirth, the obstetrician, the gynecologist and obstetrician try to pull the head forcefully so that it will come out. Number one. Number two, sometimes in childbirth, usually in childbirth, first comes out through the vaginal canal is the head of the fetus, head of the baby, better to say, or fetus nahi. Come on. But occasionally, this buttock may come out. Sometimes this shoulder may first time to come out. So, and shoulder is a very large area. Buttock is a large area, so that there is a chance of obstruction. বেরিয়ে আসতে চায় না। তখন আমরা কি করি? টানি একটু। যদি চলে আসে, if it comes. So, during handling, there might be stretching in this region, in this fashion. পুলটা করছে এরকম ভাবে, একটা সাইডে। So, there is a stretching in this area, hitting the Arps point, injuring the Arps point, damaging the C5, C6 root, nerve to suprascapular and nerve to subclavius. So, the child will born with a paralysis of the muscle supplied by this C5, C6 root and nerve suprascapular nerve. Nerve to subclavius is not very important because it only supplies the small subclavius muscle, which is not very ভালো করে কোনো clinical symptom দেখা যায় না, because it function only to steady the first rib with the clavicle. সুতরাং the baby will born due to damage of the C5, C6 root and suprascapular nerve. Paralysis হয়ে আসবে। কিভাবে আসবে? এরম ভাবে। ওয়েটার স্ট্রিপ, পুলিশম্যান স্ট্রিপ, সাধারণত তোমরা জানোই পড়েছো যে পুলিশরা যখন টিপস নেয় বা ওয়েটারের টিপ নেয়, লজ্জা পাচ্ছে, এরম ভাবে নিচ্ছে। সো এই ডিফর্মিটিকে উই কল পুলিশম্যান স্ট্রিপ অর ওয়েটার স্ট্রিপ, রাইট? হলো? কেন হচ্ছে? তাহলে আমরা দেখি। এই যে এখানে জোর করে টানছে, স্ট্রেচিং হচ্ছে এখানে, বুঝতে পেরেছো? এই যে টান পড়ছে, তাহলে এইদিকে ড্যামেজ হয়ে যাবে, এদিকে যদি টান পড়ে এটা ড্যামেজ হয়ে যাবে। এইভাবে বেবি উইল প্রেজেন্ট। বেবি যেন এসেই পয়সা চাইছে, এলাম এবার একটু দাও আমাকে, এখন থেকেই কমিশন খেতে চাইছে। আচ্ছা, কেন হচ্ছে? তাহলে আমি কি বলেছি? ডাব রুট ইনভলভ C5 and C6। একটা আমি ভুল বলেছি আজকে, ওটা আমি এখন মাথায় ভুলছে, আমি পরে কারেক্ট করে দিচ্ছি, এখন এর মধ্যে ঢুকছে না। ওই C7 রুটটা অ্যাকচুয়ালি মিডিয়ান নয়, আলনার নার্ভের জন্য হয়। হ্যাঁ, পরে আসছি। আচ্ছা, নার্ভ রুট ইনভলভ মেইনলি C5 and C6, ডিফর্মিটি অ্যান্ড মাসল ইনভলভ, ঠিক এভাবে লিখে বেরিয়ে যাবে। এবার হচ্ছে কি কি ড্যামেজ করেছে? আপার ট্রাঙ্ক C5 and C6 root and suprascapular nerve. Nerve to subclavius damage is not very seen because it only subclavius muscle is damaged. It is not very important. এবং পিকিউলারলি দেখা যাচ্ছে, এটা ভালো করে শোনো, যদি এক্সপ্লেন করো রুট ম্যাপিং দিয়ে এক্সপ্লেন করা যায়, বাট ইট ইজ বিয়ন্ড পারভিউ। ভালো করে এটা শোনো, দ্য পার্টিকুলার নার্ভ C5 C6 রুটের জন্য মেইনলি মাসলস ইনভলভ by the supplied by the axillary nerve and by the musculocutaneous nerve. এবার তুমি তো বলবে স্যার মিডিয়ান নার্ভে তো C5 C6 রুট আছে, ওটা কেন ড্যামেজ হচ্ছে না? বলবে স্যার রেডিয়াল নার্ভে তো C5 C6 রুট আছে, why it is not damaging? Yes, it can be explained by root mapping, but it is not beyond purview. তো শুধু এখন জেনে রাখো, as you are in a basic level, তোমরা জেনে রাখো, you will know only these muscles are paralyzed. What are the muscles paralyzed? Deltoid, axillary nerve, teres minor, axillary nerve, and musculocutaneous এর জন্য mainly biceps brachii. Very তিনটি important muscle paralyzed হয়ে গেল। So then you should be very cautious during childbirth, normal delivery. You should be very cautious. Otherwise, you will be responsible for this damage. And you will be sued against the court and huge money. Not only that, not money. Money doesn't matter. But the child will suffer whole life, whole life. Luckily, the damage is easily recoverable. তাহলে কি কি হচ্ছে? আমি কি বলেছিলাম? প্যারালিসিস অফ দ্য ডেল্টয়েড মাসল। তাহলে কি করতে পারবে? অ্যাবডাকশন করতে পারবে না। সো আর্ম উইল বি অ্যাডাক্টেড। এবার কি কি মাসল করছে? সুপ্রাস্ক্যাপুলার নার্ভ সাপ্লাই করে, সুপ্রাস্পাইনাটাস, ইনফ্রাস্পাইনাটাস। সো দিস আর দ্য ল্যাটারাল রোটেটরস অফ দ্য শোল্ডার জয়েন্ট। তাহলে কি হবে? আর্ম অপোজিট অ্যাকশনটা হবে। প্যারালিসিস যখন হবে তার অপোজিট অ্যাকশন হবে। তাহলে কি হবে? আর্ম উইল বি medially rotated. Lateral rotation is paralyzed. Why paralyzed? Because supraspinatus, infraspinatus is paralyzed. Why paralyzed? Due to injury of the C5, C6 root and suprascapular nerve supplying them, and nerve to suprascapular nerve is damaged. So lateral rotation is paralyzed. So medial rotator will take upper hand and arm will be medially rotated. আর কি হবে? Biceps will be paralyzed. So there is an biceps কি করে? ফ্লেকশন। তাহলে ফ্লেকশন করবে না, তাহলে এক্সটেনশন হবে। and biceps also supinator. so supination হবে না, প্রোনেশন হবে। যেই প্রোনেশন হয়ে গেল, এই টিপটা হয়ে গেল, এই টিপ দেওয়ার হয়ে গেল। so arm will be adducted, elbow joint will be extended, forearm will be pronated. Due to paralysis of the deltoid muscle, due to paralysis of the কি বললাম? supraspinatus, infraspinatus muscle, due to paralysis of the mainly biceps muscle. তাহলে একটা শর্ট নোট হয়ে গেল আর্মস প্যারালিসিস। আর কারণে হতে পারে, অ্যাডাল্টের হতে পারে, ওপর থেকে পড়ে গেল, মাথাটা এরম করে চোট খেলো, সুতরাং ফল অন দ্য হাইট, ফল ফ্রম দ্য হাইট হতে পারে, অ্যাডাল্টেরও হতে পারে। শুধু যে বাচ্চাদের হবে তাই নয়, শোল্ডার ইঞ্জুরি হলো, ওপর থেকে পড়ে গেছে, হ্যাঁ, অথবা ড্যাশবোর্ড ইঞ্জুরি হয়েছে, হঠাৎ ব্রেক চেপেছে, মাথায় গিয়ে এরম করে বেঁকে গেল, হতে পারে। মেইনলি ফল ফ্রম দ্য হাইটেও এটা হতে পারে, অ্যাডাল্টরাও এরম ভাবে আসতে পারে। টিপস চেয়ে আরেকটা প্যারালিসিস হচ্ছে ক্লামকিস প্যারালিসিস। ক্লাম্পিস প্যারালিসিসে C8CL1 টা রুট হয়, এটা খুব সহজ। এইটা C8 and P1 রুটটা ড্যামেজ হয়। কখন হয়, কি করে হয়? হঠাৎ ওপর থেকে পড়ে গেল, কোনো কারণে এখান থেকে পড়ে গেলাম, ওপর থেকে পড়ে যাচ্ছ, বুঝতে পারছো পড়ে যাচ্ছে, তখন কি করব? আমরা একটা কোনো কিছু পেলে ঝরিয়ে ধরছি, পুরো ধরো এটা একটা কিছু জড়িয়ে ধরলাম, বা একটা গাছের ওপর থেকে পড়ছে, ইট ইজ ফলিং ফ্রম দ্য ট্রি and try to catch the lower tree and whole body weight are now thrown on your shoulder, stretching this, and ultimately lower trunk or C8T1 is damaged. খুব কমন ইনজুরি কিন্তু হয়, অনেক সময় রাজমিস্ত্রিদের খুব হয়, পড়ে যাচ্ছে রাস্তায় একটা কারণ শক্তভক্ত কিছু ধরে নিল, প্রচন্ড হোল বডি 60 কেজি ওজন ওর এটার উপরে পড়লো, স্ট্রেচড হয়ে গেল, অ্যান্ড লোয়ার ট্রাঙ্ক ইজ ড্যামেজড। এবং কি ড্যামেজ হয়? লাকিলি C8T1 এর জন্য খুব বেশি ড্যামেজ হয় না, আলনার নার্ভটা ড্যামেজ হয়, ফলে ইন্ট্রিনসিক মাসেলস এই যে এবং লুম্ব্রিকালস ইন্টারঅসিয়ার ড্যামেজ হয়, ফলে ক্ল হ্যান্ড হয়। বাস, এটা সহজ। আর অনেক সময় বার্ট ইঞ্জুরিতেও হতে পারে। সো ইন্ট্রিনসিক মাসেল অফ দ্য হ্যান্ড, আনলার ফ্লেক্সার্স অফ দ্য রিস্ট অ্যান্ড ফিঙ্গার্স আর ড্যামেজড, মেইনলি আনলার নার্ভ। আর কি হয় এখানে, আর কি হয়? এটা আমরা এখন করবে না, থোড়া সেকশন করবে। আগেই বলেছি D C5 C6 C7 C8 T1 root carries sympathetic fibers, and these sympathetic fibers are damaged, giving rise to a syndrome known as the Horner syndrome, which is going to these sympathetic fibers, অনেক টাইম লাগবে, নাহলে বলতাম যে superior cervical ganglion এ যায় and it supplies the eye muscle etc. and face. So ultimately it causes, এটা কিন্তু তোমাদের, though it is not written here, কিন্তু finally when you pass through it will be asked. So not only the intrinsic muscles of the hands are damaged producing claw hand, it also produces sympathetic nerve injury resulting into Horner syndrome. What is Horner syndrome? Anhidrosis. এইদিকে সোয়েটিং হবে না, যে সাইডে এফেক্ট হবে there will be no sweating. Point pupil, call it meiosis, পিপিলটা ছোট হয়ে যাবে। টোসিস, এই যে পাতা তুলতে পারবে না, লোয়ার আইলিড ড্রুপিং হবে, সিলোস্পাইনাল রিফ্লেক্স দরকার নেই, আর এনপথ্যালমাস, চোখটা ঢুকে যাবে ভেতরে। সো দিস অল টুগেদার ফর্ম দ্য হর্নার সিনড্রোম। আচ্ছা, কার কোন দিকের হর্নার সিনড্রোম হয়েছে বলো তো? ভেরি গুড, লেফট। এই যে এটা হচ্ছে নর্মাল, এই ছোট হয়ে গেছে, প্লাস দেখেছো চোখের পাতাটা পড়ে আসছে, আইলিডটা। সো এই ক্লাম্পিস প্যারালিসিসে হর্নার সিনড্রোম হয়। দিস ইজ দ্য পিকুলিয়ার অফ দ্য ক্লাম্পিস প্যারালিসিস, ক্ল হ্যান্ড, ক্ল হ্যান্ড। আরেকটা কি হয়, আগেই বলেছি, নার্ভ টু সেরেটাস অ্যান্টেরিয়র মে বি ড্যামেজড। নার্ভস টু সেরেটাস অ্যান্টেরিয়র মে বি ড্যামেজড ইফ দ্য রুটস আর ড্যামেজড। সো দেয়ার ইজ এ উইঙ্গিং অফ দ্য স্ক্যাপুলা হতে পারে, পড়েছে, আর ডিটেলস যাচ্ছি না। এই যে দিস ইজ দ্য সেরেটাস অ্যান্টেরিয়র নার্ভ, এই নার্ভ টু সেরেটাস অ্যান্টেরিয়র মে বি ড্যামেজড ডিউরিং অপারেশন অন দ্য দিস রিজিয়ন, resulting into loss serratus nerve palsy, resulting into winging of the scapula. Brachial plexus block. Sometimes, especially severe cancer, severe pain, there is no remedy of pain. Patient সহ্য করতে পারছে না, patient cannot tolerate this pain. Plus, এটা গেল একটা reason. Number two, some operation can do, but we don't want general surgery, a general anesthesia. পুরো অজ্ঞান করে করব না। এখানে করলে তো এপিডুরাল, সাবডুরাল করতে পারি। এইখানে আমরা কি করতে পারি, একটা অ্যানাস্থেটিক এজেন্ট ব্রেকিয়াল প্লেক্সাসে দিয়ে দিতে পারি, এখানে দিব্যি উই ক্যান ডু পেনলেস অপারেশন, তখন উই রিকোয়ার ব্রেকিয়াল প্লেক্সাস ব্লক। আমরা এখান দিয়ে ঠিক ক্ল্যাভিকেলের নিচ দিয়ে আল্ট্রাসোনো গাইড লাগে, কিন্তু আগে হতো না। আল্ট্রাসোনো গাইড, আন্ডার আল্ট্রাসোনো গাইডেড উই পুট এ নিডল গোজ, আল্ট্রাসোনো দেখে 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 ব্রেকিয়াল প্লেক্সাসে যাব, পুশ অ্যানাস্থেটিক এজেন্ট অ্যান্ড nerves are sensory paralyzed, sensory loss will be there, we can do operation, after some time recovery will be there and patient will be okay. So without doing anesthesia we can block the brachial plexus. এই যে brachial plexus block করা হচ্ছে ultrasono guided. This is the probe, brachial plexus block করা হচ্ছে। এটা হচ্ছে suprascapular approach, there may be a supraclavicular approach, there may be infraclavicular, supraclavicular in different region. এই যে anesthetic brachial plexus এ ব্লক করছে। ফার্স্ট দ্য মোস্ট ইম্পর্টেন্ট, দেখো সব জিজ্ঞেস করে না পরীক্ষায়, যদি সব পড়তে যাও মনে রাখতে পারবে না, আমি যেটা বলছি সেটা পড়ো। ফার্স্ট যেটা বোন টোটাল অসিফিকেশন পড়তে হবে, দ্যাট ইজ দ্য ক্ল্যাভিকল। ক্ল্যাভিকল হ্যাজ গট এ পিকুলিয়ার অসিফিকেশন। Why it is a long bone? Because obviously clavicle has got a length greater than breadth. একটা reason লিখে রাখো, why clavicle is a long bone? Length is greater than, it has got a length greater than breadth. Obviously it has got a shaft and two ends, acromial end and sternal end. As a long bone has got a length greater than breadth, long bone has got a middle shaft and two ends, upper end and lower end. Whether it may be, clavicle has got a shaft and a two ends, medial end and lateral end. Number 3, one of the most important point of the clavicle is that why it is a long bone? Long bone usually transmits body weight and clavicle transmits body weight. So we call it, it is a long bone. So we call it, it is a long bone because its length is greater than breadth. Number 1, it has got a middle shaft and two ends. Number 3, it transmits weight, body weight. আমাদের superior extremity weight clavicle দিয়ে transmit করে। So it is a long bone, but it has got a peculiarity. So it is called a modified long bone. Why it is a long modified? Because usually long bone has got cartilaginous ossification, but clavicle is mainly, total লিখবে না, mainly membranous ossification, except its sternal end which has got a cartilaginous ossification. Right? So গেল। Number 2, usually long bone is deeply placed, covered by a muscle. আমরা জানি femur is all round covered by a muscle, radius covered by a muscle, but clavicle is a subcutaneous bone. দেখো স্কিনের পরই clavicle, not covered by a muscle. So it is a special type. So we call it modified. Number 3, number 3, it has no medullary cavity. সমস্ত লং বোনের মেডুলারি ক্যাভিটি আছে যেখানে ব্লাড সেল ফর্মেশন হয়। ক্ল্যাভিকল হ্যাজ গট নো মেডুলারি ক্যাভিটি। নাম্বার 4, অ্যানাদার পিকুলারিটি, ইট ইজ পিয়ার্সড বাই নার্ভ। কোন বোনস পিয়ার্স, নার্ভকে পিয়ার্স করে? নো, বাট ক্ল্যাভিকল ইজ এ বোন হুইচ ইজ পিয়ার্সড বাই নার্ভ। আর কি ইউনিক ফিচার আছে ক্ল্যাভিকলের? ইট ইজ দ্য ফার্স্ট বোন টু অসিফাই। এটার জন্য কিন্তু ইয়ে নয়, মানে পিকুলারিটি নয়, এটা জানার জন্য ইউনিক। ইউনিক মানে কি? স্পেশাল, যেটা ওর আছে এর নেই। ইট ইজ দ্য ফার্স্ট বোন টু অসিফাই অ্যান্ড লাস্ট বোন অফ ফিউশন। প্রথম বোন অসিফাই করে এবং সবচেয়ে শেষে অসিফিকেশন কমপ্লিট হয়। কেমন? তাহলে এইগুলি হচ্ছে ক্ল্যাভিকেল। তাহলে অসিফিকেশন অফ দ্য ক্ল্যাভিকেল, ossification of the clavicle is a partly membranous, mainly membranous and partly cartilaginous. The first bone to ossify, oh arekta peculiarity ache, each bone usually has got a single primary center of ossification. Femur, radius, ulna, humerus all have got single primary center of ossification. In clavicle, two primary center of ossification appears in membrane at about 5th to 6th week of intrauterine life. So clavicle has got two primary center of ossification. সমস্ত বনে সিঙ্গেল প্রাইমারি সেন্টার, হিউমারাস 8th week of intrauterine life single, radius 8, সবই 8, কিন্তু এইখানে আর্লিয়েস্ট 5th to 6th week of 5th to 6th and it occurs in membrane, not in cartilage. And they soon join together, এই দুটো জয়েন করে membranous ossification হয়ে bones formation হবে। সরি, এই জায়গাটা বাদ দিয়ে, স্পাইনাল এন্ড বাদ দিয়ে, and the sternal end has got a secondary center appears after birth at about 6th year, and it is a cartilaginous, it is a membranous ossification. And sternal end, it is the sternum. It is the sternal end, it is a cartilaginous ossification. And it joins with the end, সবার শেষে সব bones join করে গেল at about 21 to 22 years. আচ্ছা, আরেকটা কথা বলে দেই, তোমাদের ক্ল্যাভিকেল পড়েছো, কোন জায়গাটায় ক্ল্যাভিকেল সবচেয়ে বেশি ফ্র্যাকচার হয়? Medial to the lateral 1/3. It is the old view. It is the old view. অবশ্য অনেক এক্সামিনার জানে না। The recent view is that clavicle is fractured at the region of the lateral 2/5 and medial 2/5. It is the recent view. অলমোস্ট ওই দিকটায়, কোরোনার প্রসেসে না, কোরোনার প্রসেস তোমার স্ক্যাপুলার, তোমার জাস্ট মিডিয়াল 2/5 আর ল্যাটারাল 2/5 এই জায়গাটা। আগে বলা হতো এইখানটায় ফ্র্যাকচার হয় কমন ডি টু কার্ভেচার, দেখা যাচ্ছে এইখানটায় স্ট্রেস বেশি পড়ে, ল্যাটারাল 2/5 অ্যান্ড মিডিয়াল 2/5 এর। এটা না জানলেও ক্ষতি নেই, অনেকে জানে না, মানে রিসেন্ট গ্রেতে এটা লিখেছে, তার জন্য একটু বলে দিলাম। তাহলে এটা গেল ক্ল্যাভিকেলের অসিফিকেশন, অফেন আস্কড। তারপরেরটা পার্টলি পড়বে হিউমারাসের, কোনটা পড়বে বলে দিচ্ছি। হেড, গ্রেটার টিউবারকেল, লেসার টিউবারকেল। আপার এন্ডটা ভালো করে পড়বে। Humerus. It is a cartilaginous ossification. No, কোনো ঝামেলা নেই। So, a primary center of ossification appears before heart at about 8th week of intrauterine life. 8th week of intrauterine life. বেবি বর্ন হলো, এগুলি সব কার্টিলেজ হয়ে রয়েছে। এই জায়গাটা বোনস অলমোস্ট তৈরি হয়ে গেছে, এইগুলি সব কার্টিলেজ রয়েছে। যখন বেবি বর্ন রয়েছে, ইট ইজ ইউজুয়ালি কার্টিলেজ, ভেরি রুডিমেন্টারি। নেক্সট, the secondary center of ossification appear. In the upper end, secondary center of ossification appears at about, in the head, 1 year. In the greater tubercle, 3 years. Lesser tubercle, 5th year. One year, 3 year, 5th year, bone formation হলো। এইবারে বলো তো কি গ্রোয়িং এন্ড অফ হিউমারাস কোনটা, আপার এন্ড না লোয়ার এন্ড, কিভাবে মনে রাখি? পরীক্ষায় জিজ্ঞেস করবো তো, গ্রোয়িং এন্ড কিভাবে মনে রাখা হয় জানো না? হ্যাঁ, হাউ ডু নো দ্য গ্রোয়িং এন্ড? ভেরি ইম্পর্টেন্ট সার্জিক্যাল অর্থোপেডিক্স এর ক্ষেত্রে। না জানলে অপারেশন করবে কি করে, অ্যাম্পুটেশন করবে কি করে? গ্রোয়িং এন্ড মানে কি? A long bone has got a 2 ends, upper end, lower end, right? তাদের মধ্যে একটা লাস্টে ফিউশন করে বডির সাথে। ধরো আপার এন্ড ফিউশন করছে 15 ইয়ার্সে, আমি বলছি, লোয়ার এন্ড ফিউশন করছে 17 ইয়ার্সে। তাহলে কোনটা গ্রোয়িং এন্ড হবে এখানে? আমি এটা এখনো বলিনি, কিন্তু এটা বোঝানোর জন্য। কোনটা গ্রোয়িং এন্ড হবে? একটা বডি ফিউজ করে যাচ্ছে 15 বছরে, ধরো আপার এন্ডটা একটা, এইটাকে ধরবো না, একটা এন্ড, এটা একটা বোন, এটা 15 ইয়ার্সে ফিউশন করে যাচ্ছে, এটা 17 ইয়ার্সে ফিউশন করছে। কোনটা গ্রোয়িং এন্ড? লোয়ার এন্ড। কারণ একবার ফিউজ করে গেলে আর গ্রো করবে না। ওয়েন্স ইট ফিউজেস উইথ এ ডায়াফাইসিস, ইট উইল নেভার গ্রো। এইটা যেহেতু পরে ফিউশন করছে, এটা আরো লম্বা হবে। সো লোয়ার এন্ড ইজ গ্রোয়িং এন্ড হিয়ার। বাট হাউ ডু রিমেম্বার হুইচ ওয়ান ইজ এ গ্রোয়িং এন্ড? একটাই রাইম দিয়ে, কবিতা দেখে, সে হচ্ছে টুয়ার্ডস এলবো আই গো, ফ্রম নি আই ফ্লি। জানো তো? এটা জানো না? হ্যাঁ, তোমাদের জেনারেল এন্ড তুমি এইটা জানো না, টুয়ার্ডস এলবো আই গো, তাহলে পারবে কি করে গো? বেসিক একদম প্রথমে জানতে হয়, এটা সারা জীবনে জানতে হবে। তাহলে তোমরা যে ক্লাস করো না, বই থেকে এসব লেখা আছে, আছে বইতেও আছে, টুয়ার্ডস এলবো আই গো, ফ্রম নি আই ফ্লি। আইটাকে, আই হচ্ছে নিউট্রিয়েন্ট ফোরামেন, আই হচ্ছে একটা বোনসের নিউট্রিয়েন্ট ফোরামেন। ব্যাপারটা কি? একটা বোনের ক্ষেত্রে একটা নিউট্রিয়েন্ট ফোরামেন থাকে, and nutrient foramen, if you examine nutrient foramen, it is not like this. এরকম নয়, আইদার এরকম অথবা এরকম। একটা ডিরেকশন আছে নিউট্রিশন ফোরামেনে, দেয়ার ইজ এ ডিরেকশন। ইন কেস অফ এ হিউমেরাস কি বলেছি, টুয়ার্ডস এলবো আই গো, ডিরেকশনটা হচ্ছে এরকম। এখানে তো এলবো আছে, তো এটা তো এলবো জয়েন্ট, হ্যাঁ এটা এলবো জয়েন্ট আর নয়। আমি এখানে আরো ছোট করে আঁকি, অবস্থা খারাপ। নিউট্রিয়েন্ট ফোরামেনের ডিরেকশনটা এরকম, টুয়ার্ডস এলবো আই গো, এটা হচ্ছে এলবো জয়েন্ট, তাহলে নিউট্রিয়েন্ট ফোরামেন ইজ গোয়িং অ্যাজ ইফ গোয়িং টুয়ার্ডস এলবো। তাহলে এখানের ক্ষেত্রে কি হবে ডিরেকশনটা, এই রকম। ফ্রম নি আই ফ্লি, ফিমানের ক্ষেত্রে হবে, তাহলে এখানে ডিরেকশনটা ফ্রম নি আই ফ্লি মানে আমি দূরে চলে যাচ্ছি, তাহলে এখানে ডিরেকশন কিরকম হবে, এই রকম, এই রকম। এটা হচ্ছে নিউট্রিয়েন্ট ফোরামেনের ডাইরেকশন। এরপরে নিউট্রিয়েন্ট ফোরামেনের যেদিকে ডাইরেকশন তার অপোজিটটা হচ্ছে গ্রোয়িং এন্ড। তাহলে এইটার ডিরেকশন যদি এরকম হয় তাহলে গ্রোয়িং এন্ড হচ্ছে আপার এন্ড, বুঝতে পেরেছ? এটার গ্রোয়িং এন্ডটা কি, লোয়ার এন্ড, এটা গ্রোয়িং এন্ডটা কি, আপার এন্ড। এটা মনে রাখবে, কারণ গ্রোয়িং এন্ড কখনো ড্যামেজ করা যায় না, মানে বিফোর ফিউশন একটা 15-16 বাচ্চাদের গ্রোয়িং এন্ডটাকে লক্ষ্য রাখতে হবে। একটা অ্যাম্পুটেশন করে দিলে এখানে হুপ করে পায়, এটার গ্রোয়িং এন্ডটা কি হচ্ছে, হিউমারাসের আপার এন্ড। কেমন, আপার এন্ডটা একটা অপারেশন করে দিলে, অপারেশন চলে গেল, হয়ে গেল, ইটস কমপ্লিটেড, কিছুক্ষণ পর বলবে ব্যথা, কেন, ওটা তো গ্রো করতে আরম্ভ করেছে, ফলে তোমার অপারেশন ফেলিওর হয়ে যাবে। এখানে অ্যাম্পুটেশন করলে, খেয়াল রাখলে না, কিছুদিন পর হাড়টা বড় ফুটো করে বেরিয়ে যাবে, চামড়া ফুটো করে বেরিয়ে যাবে, গ্রোয়িং এন্ড। সুতরাং ইট শুড বি রিমেম্বার, কেমন? তাহলে গ্রোয়িং এন্ডটাকে হিউমারাসের আপার এন্ড আর লোয়ার এন্ড, ও বলে দেবে, দেখবে এখন আমার, হ্যাঁ, আপার এন্ড ইজ দ্য গ্রোয়িং এন্ড। তাহলে ফিউশন আগে হবে না পরে হবে লোয়ার এন্ডের, হ্যাঁ, পরে হবে না আগে হবে, আগে হবে। গ্রোয়িং এন্ডটা ফিউশন বডির সাথে আগে হয় না পরে হয়, পরে হবে। গ্রোয়িং এন্ডটা পরে হবে, কারণ গ্রো করবে তারপরে লাস্টে জয়েন করবে কম্পারিজন টু আদার এন্ড, বুঝতে পেরেছ? এগুলি বেসিক জিনিস। এরপরে যখন সেকেন্ড ইয়ারে যাবে না বলতে পারলে বলবে এই অ্যানাটমিতে কিচ্ছু শিখে আসেনি। এইগুলি পড়তে হবে তোমাদের, বেশি পড়ে লাভ নেই, বেশি ডিপ যে ও এই বেসিক জিনিস জানতে হবে। আচ্ছা, ব্যাক টু প্যাভিলিয়ন। আচ্ছা, তাহলে কি বললাম, এই আইডিয়াটা দিয়ে আমি যাচ্ছি। তাহলে প্রাইমারি সেন্টার 8th উইক অফ ইন্ট্রা-ইউটেরাইন লাইফ, রাইট? আচ্ছা, হেড অ্যাপিয়ার করছে 1 ইয়ার, গ্রেটার টিউবারকুল 3 ইয়ার, and lesser tubercle করছে 5th ইয়ারে অ্যাজ এ সেপারেট, একভাবে নয়। এটা একটা এপিফাইসিস হলো, এটা একটা এপিফাইসিস হলো, অ্যান্ড এটা একটা এপিফাইসিস হলো। So 3 epiphyses appear, one at 1 year, one at 3 year, one at 5 year. Ultimately, all these 3 epiphyses join together to form a single epiphysis at about 7 year. তাহলে আলাদা আলাদা এপিফাইসিস, ভালো করে শোনো এটা, আলাদা আলাদা এপিফাইসিস হয়েছিল, one for head, one for greater tubercle, one for lesser tubercle. They all join together to form a single epiphysis at about 7 years. And these type of epiphyses, which are initially separated, then joins together to form a single epiphysis. We call them as a compound epiphysis. এই যে এপিফাইসিস, এটাকে বলি আমরা কম্পাউন্ড এপিফাইসিস। আর যে এপিফাইসিস ডাইরেক্টলি জয়েন করছে ডায়াফাইসিসের সাথে, তাকে আমরা বলি সিম্পল এপিফাইসিস। And ultimately this compound epiphysis joined with the sap at about 19 to 20 years, as it is a growing end. এইটা তোমাদের অবশ্যই মনে রাখতে হবে। লোয়ার এন্ড ইউজুয়ালি কেউ জিজ্ঞেস করে না, ইউজুয়ালি জিজ্ঞেস করে না, তাও আমি বলে দিচ্ছি। লোয়ার এন্ড ফার্স্ট secondary epiphysis appear, first epiphysis appear in the capitulum and the lateral part of trochlea at about 2nd year. Next, medial part of trochlea 10 years. Then lateral epicondyle 12 years. They are also compound epiphyses because these all together they join to form a single epiphysis at about 14 years and join with the shaft at about 17 years to 18 years. And medial epicondyle is a simple epiphysis. It appear at about 8 years and join at about 18 years. Lower end না জানলেও হবে। এরপরে যেটা আসছি মোস্ট ইম্পর্টেন্ট, তোমরা কম্পাউন্ড এপিফাইসিস ভালো করে শুনবে, নিউট্রিয়েন্ট ফোরামেনের ডাইরেকশন অ্যান্ড গ্রোয়িং এন্ড ভালো করে পড়বে বাড়িতে গিয়ে। জেনারেল অ্যানাটমি বইতে পাবে, ইট উইল বি রিটেন ইন জেনারেল অ্যানাটমি বুক। নেক্সট, আলনা। আলনা খুব ইজি, ঝামেলা কিছু নেই। Primary center, 8th week of uterine life. Upper end at about secondary epiphysis appears after birth 9 year and it is about 6th year. Lower end 6th year secondary epiphysis. জানলেও খুব একটা জিজ্ঞেস করে না। So it is the lower end is the growing end. So it joins with 15 to 17 years. It is 18 to 19 years. ছেড়ে দাও। Next is the radius. It is often asked. Primary center, 8th week of intrauterine life. সবারই এক। 8th week of intrauterine life, cartilaginous ossification. The upper end appears about 5th year, lower end at about 1 year. Growing end is the lower end, so it joins with the sap about 16 to 17 years. It joins with the sap 17 to 19th years. এক লাইন মনে থাকবে। যেটা লাস্ট যেটা বলছি সেটা খুব জিজ্ঞেস করে, সেটা হচ্ছে কার্পাল বোনস। তোমাদের skeleton of the hand usually given in the practical viva osteology table, and already you know these are the carpal bones. It has got a scaphoid, lunate, triquetral, pisiform, trapezium, trapezoid, capitate and hamate. তাই তো? Proximal row, scaphoid, lunate, triquetral and pisiform. Scaphoid, lunate, triquetral, pisiform. Trapezoid, এটা মনে রাখবে, আগে আরো সহজ ছিল, রিসেন্টলি
আগে আমরা 1 2 3 4 5 6 8 12 করে মনে রাখি, এখন আগে না কঠিন হয়ে গেছে। 3 months অ্যাপিয়ার করছে due to development of MRI and other things. We change the আমরা বলেছিলাম একটা পুরো কাউন্টার ব্লক 1 year 2 year 3 year 4 year 5 year 6 year অ্যাপিয়ার এখন তো সহজ না, এটা 3 months 3 months। তারপরে ট্র্যাপিজিয়ামে অ্যাপিয়ার করে 3 years 4 years 5 years 5 years 5 years and pisiform 12 years এরকম ভাবে। Capitate and hamate, তাহলে আপনি যদি এটা এরকম ভাবে না লিখে এরকম ভাবে আপনি scaphoid, lunate, triquetral, pisiform, scaphoid, lunate, triquetral, pisiform, trapezium, trapezoid, trapezium, trapezoid, capitate, hamate. 3 months, 3 months. তারপরে 3 years, 4 years, 3 years, 4 years, years 5 years, after that 5 years, 5 years and 12 years. আমি আমাদের সব খুব সহজ, আমি এভাবে করতে পারি 1 2 3 4 5 6 7 দেখুন দেখা যাচ্ছে চেঞ্জ 3 months 3 years 4 years 5 years 5 years 5 years দেখতে দিচ্ছি। আচ্ছা লাস্ট লাইন মধ্যে একটা ছেড়ে দেব, এটা আমরা জানি it is a long short bone। কেন লং শর্ট বোন বলছে তো বলতে পারবে? স্পেশালিটি সমস্ত শর্ট বোনে এই লং বোনে একটা there is a one primary center of ossification
and 2 secondary center of ossification, upper end, lower end, maybe multiple. But in case of a metacarpal, which is called often miniature long bone, it has got a one primary center of ossification and one secondary center of ossification, not two. In case of a hand, suppose it is the lateral end, it is the 1, 2, 3, 4, 5. It is the first thumb. It is the head it is the base. It is the head, it is the base. It is the head, it is the base. All appear at about 8th week of intrauterine primary center of ossification. Nothing worry. But in case of a second to fifth metacarpal bones, the secondary center of ossification appears in the head region of the metacarpals. But যেটা পরীক্ষায় জিজ্ঞেস করে, only in the first metacarpal bone, secondary center of ossification appears in the base.
Stick by which we can put a point like this. Suppose head of the ulna. How we can identify? Just we have to pronate this is supinated arm and this is the pronated arm. And when we flex the wrist, then we can find there is a prominent bulging on the medial side. Prominent bulging. Over which we can put a point. We can put a point here. Similarly, if we want to draw a line, this is for drawing a line. Suppose that there is an artery. Suppose there is an ulnar artery. How we can then first we have to identify some points like this, and you can be and giving. Okay. Okay. Then I can join these lines with two parallel lines. So that artery is a tubular structure. It should be drawn with the help of two parallel lines. Though I have made a greater distance in between the line, because you can see it from the distance. Okay. Similarly, for the nerve, suppose there is ulnar nerve, we can put a point here, we can put a point here, we can put a point here. But in case of nerve, it should be drawn using one single line, like this. This is the way of making a surface projection of the anatomical structure, and that is called the surface anatomy. Okay. And for the nerve, if there is a colored powder, like a yellow powder, that will be very nice. And for the artery, it should be a pink or red colored powder. So you have to choose the. We can see this is the abduction and this is the adduction. So due to long standard process of the radius, this abduction is less, whereas due to the short standard process, the adduction is more. The angle of adduction is more than the angle of abduction. Why? Because of the fact Radius Geiger process is 1.25 centimeter below than the ulnar stylus process. So now wait. Washer. Hammer. Hammer কোথায়? Where we will get the hammer? In the forearm. In the carpal bones. There are 8 carpal bones. They are arranged in proximal and distal rows. Right? So, you can see the proximal row and distal row. The proximal row from lateral to medial, scaphoid, lunate, triquetral, pisiform, trapezium, trapezoid, capitate, and hamate. Okay. Very much interested uttered something. Something is bubbling inside, and he wants to utter something immediately. Because he knows how to remember that one. So she looks to then scaphoid, lunate. Okay, scaphoid, lunate. Triquetral and pisiform, trapezium, trapezoid, capitate, and hamate. So we can see this hamate, which has got a hook. There is a hook. Okay, it's a hammer-like hole, and it has got hook. So it is in the medial side. How we can feel it? You know, this is the thenar eminence, or this is the thenar eminence, and this is the hypothenar eminence. At the center of the hypothenar eminence, we have to press. At the center of the hypothenar eminence, we have to press. In your hand, just feel it. At the center of the hypothenar eminence. At the center of the hypothenar eminence, you just feel it. And you will feel a pain if you press it. Because of the fact you are pressing the hook of the hamate. There is a hook of the hamate. So we can feel it. And this hook of the hamate is around the medial border of the ring finger. You can feel it is at the level of, if we draw a line, it will pass through the medial border of the ring finger. So here we can find the center of the hypothenar eminence. Now about the beginning of the brachial artery. Brachial artery or median nerve or ulnar nerve or radial nerve. Because only single point can depict all these. Okay. So number 9. How we can see the point? We know this is the axilla. Axilla has got anterior fold and posterior fold. Anterior fold and posterior fold. And if we feel the fold, if we feel the fold, the anterior fold, we can feel the lower end of the axillary fold, anterior axillary fold, and we also can feel the lower end of the posterior axillary fold. Okay? And we can, suppose this is the lower end of the axillary fold, anterior axillary fold, and this is the lower end of the posterior axillary fold. Okay? And now we will join these 2 points. Okay? So lower end of the anterior axillary fold we have to search out, and lower end of the posterior axillary fold we have to search out, and we will make a line. You can see, we can very good. So this is the line joining the anterior and posterior axillary fold. Now, anterior 2/3 and we have to point out the junction between the anterior 2/3 and posterior 1/3 of this line. Anterior 2/3 and posterior 1/3. We have to make a point. This is the point which shows the beginning of the brachial artery or beginning of the median nerve or beginning of the ulnar nerve or beginning of the radial nerve. Only this point. How we can draw it? First we have to search the anterior axillary fold and the posterior axillary fold. The lower end of the anterior and posterior axillary fold we have to join. We will get a line. Then we have to point out the anterior 2/3 and posterior 1/3 of the line. And there we will put a point. You know that the straight line is formed by joining so many points. No, joining 2 points. But 2 points is again very hectic. Within that point there might be so many points. Limit tends to extend. Or tends to 0 also. So this is the point. So this is the beginning of the brachial artery. This is the beginning of the median nerve. This is the beginning of the ulnar nerve. This is the beginning of the radial line. ঠিক আছে? This is very important point because একটু পরে বুঝতে পারবে। Now we have to draw the lines. The first line is left axillary artery. Axillary artery is within the axilla. This point is the end, the beginning of the brachial artery. So we can say this is the end of the axillary artery. So we can say this is the end of the axillary artery. Then where is the beginning? We have to feel the clavicle. Okay. Actually, it is extent is when the subclavian artery crosses the first rib, it becomes the axillary artery. Right? But we cannot see the, we cannot feel the first rib. It is being obscured by this clavicle. Okay. You can see here. Clavicle is clavicle actually obscures the first rib. Okay, we cannot look it. You can see it here. Now we have to feel. We can feel what we can feel. We can feel the clavicle. This is the sternal end, and this is the acromial end. And we have to make a middle point. We have to make a middle point just below the clavicle. Okay. Midpoint of the acromial and the sternal end. And just below it, you need puta point. Here. Now we will join these 2 points with a line, with a single line, double line, triple line. Artery is the tubular structure. Double line. Okay. The one should be here, and another should be here. So what we try to what we do. Very nice. What? তোমার ট্রিটমেন্ট করে আসবে তুমি ঘোরাতে পারো এটা ঘোরানোর ব্যবস্থা আছে এই জন্যই রাখা হয়েছে যাতে তুমি কার্ড করতে পারো তুমি কাজ করে ঘুরে আসবে তো axillary artery is convex upwards when the arm is against the chest. Okay, convex upwards. It becomes straight when the arm is straight, and when it is above, okay, the full abduction, it becomes concave. Okay, convex, straight, concave. So this is the axillary artery, or the left axillary artery. Surface projection. Surface anatomy means surface projection of anatomical structure, and might be anything: artery, nerve, vein, viscera, like stomach, heart, lung, everything. Then is the brachial artery. This is the beginning of the brachial artery within the brachium or the arm. Okay? Brachial artery means not the femoral artery. In femoral we will get the femoral artery. Brachial artery to say the femoral have that. So what the সমস্যার কাছে গেলে তো ফিউচার প্ল্যান কি আমাকেও বলতে দেবে So this is the brachial artery. This is the beginning point. Another point We know the tendon artery nerve. This is the biceps tendon. Biceps tendon. You can feel the biceps tendon. Just medial, just flex the elbow. You can feel the biceps tendon and just medial to it, tendon, artery and nerve. Okay, just 1 centimeter below the elbow, it bifurcates into radial artery and ulnar artery. So this is the last point. Okay, so we can put another point here. বুঝতে পারছো বাবারা মামুরা when I repeat for the first time at least 60% of the students will understand. When I will repeat it for the second time around 90% of the students will understand. When I repeat for the third time almost 98% students will understand. Rest 2% student will never understand. Whatever might be the number of repetition. So you have to be very attentive. Okay. The first point is the beginning of the brachial artery which we have already drawn. The next point is we have to flex the elbow, we can feel the bicep tendon and just medial to the tendon is the artery and we will go 1 centimeter below the 1 centimeter below the elbow joint level where it bifurcates. So we will put a point here. Okay? And we will join these 2 points. By 2 lines. One is above the point, one is below the point. Very nice. Very nicely drawn. Okay. So this is the brachial artery. Next is the radial artery in forearm. Radial artery এখানে থাকবে না এখানে থাকবে Radius is on this side or on this side. So the radial artery should be here. The first point is already given. The bifurcation of the brachial artery is the beginning of the radial artery or of the ulnar arteries. Brachial artery to radial artery হয় মনে হচ্ছে brachial artery divides into right? On the lateral side, this is the radial. On the medial side, this is the ulnar. This is the radial artery. Okay. The left arm, left forearm. Okay. So first point is already given. Then we have to start the next point here. How we can plot the forearm tendons, and we will get. We will see the flexor carpi radialis tendon. This is the flexor carpi radialis tendon. This is the flexor carpi radialis tendon. This is the flexor carpi radialis tendon. Okay. Go lateral to it. and you will feel the pulse of the radial artery. When we can feel the pulse, so there, which is against the radius, lower end of the radius. This radial artery resides over the lower end of the anterior surface of the radius. So we can put the point here. So here is the point, we can feel it. Feel also exactly watch whether you are feeling the pulse or not. And you can, if you can identify this statement, very good. So put the point here. Now we will join this. Very nice. And বাড়িতে না জানিয়ে কি করবে? এসিটা না জানিয়ে So this is the radial artery. Okay. The next one is the ulnar artery in the forearm. We have to feel the pisiform bone. This is the pisiform bone. Already we have seen the pisiform bone. Pisiform. The extracarpal arteries ends here, and we can feel a sheet-like bone. That is a pisiform bone. Thus, lateral to the pisiform bone, we will put a point. Now we can join. Very nicely drawn. One is radial, one is we are taking much time. Then is the superficial ulnar arch. Continuation is the ulnar artery. We have to put a point. The first point is here, already given. The second point is at the center of the hypothenar eminence. Center of the hypothenar eminence. Okay. Now we will stretch the thumb. Okay. We will stretch the thumb like this, and we will put a line through the distal end of the outstretched arm. This is the proximal end, and this is the distal end. This is the proximal end of the outstretched arm, and this is the distal end, through which we will draw a line. Now, this is the lower limit. Now we will take a curved line, joining this point, and we will extend up to this point. So first we have to put a point over the pisiform bone. Just lateral to the pisiform bone, we have already got 1 point. The next point is the center of the hypothenar eminence, and the last line is the limiting line to the outstretched, the distal border of the outstretched thumb. And then we can draw a line like this. So this is the superficial palmar arch. This superficial palmar arch actually joins with your radial is something to join together. So this becomes the arch. So this is the superficial palmar arch. You can see it contributed by mainly by the ulnar artery and also a superficial branch of the radial artery. And there are superficial palmar arch and deep palmar arch. That's why the hand is very much warm even during winter. Very hard. And blood is warm. Next is radial nerve in the back of the arm. Now we can. Back to you. We know that was the first point about down. This is the beginning of the brachial artery. This is the beginning of the radial artery, radial nerve. This is the beginning of the ulnar nerve. Or medial nerve. So this is the first point. And we know in the back, the nerve actually follows the spiral groove. The first point is here. And then if we follow this groove, and we have to take a point, the next point. How we can make it? We have to see the insertion of the deltoid. This is the insertion of the deltoid fluid. And we have to feel the lateral epicondyle. Lateral epicondyle. Point down. Lateral epicondyle and insertion of the deltoid now. Insertion of the deltoid in the deltoid tuberosity. Now we can draw a line, thin line, joining these 2 points. We will get a line, equation. We can see a line. Over this line, the line is how we got this line. The first point is the insertion of the deltoid. The second point is the lateral epicondyle. We have joined these 2 points. So we got one line. Now we can identify the upper 1/3 and lower 2/3 of the line. Upper 1/3 and lower 2/3. You will see that. How will you find out? Very important point. And this is the second point of the radial nerve. First point we have already got it here. So, we can find the radial nerve in the spinal groove. Okay, radial nerve in the spinal groove or arteria profunda brachial in the spinal groove. Arteria profunda brachial is not within your syllabus. Only the radial nerve in the back of the arm. The first point is already anterior, posterior, axillary fold, the lower limits, join a line, then anterior 2/3 and posterior 1/3. Put a point there. This is the first point. The second point, the insertion of the deltoid at the lateral epicondyle, join a line and put a point over the upper 1/3 and lower 2/3. We'll get a point there and we will join these 2 points. Okay. We can make the radial nerve in the spinal groove or radial nerve in the back of the arm. Okay, এটার জন্যই তো তোমার এরকম ঘুরে গেছে কেন বলেছে ইমারেন্সের সাথে আলনার this is the carrying angle like this we can draw a bucket from the ground so there should be a free space যদি এরকম হয়ে যায় that is difficult. So nature has made an angulation. So, and this is the angulation. Okay. So in female it is less because the pelvis is wide. So nature has provided a wide, less angulation. And it is around 164 degrees. The next point is the ulnar nerve in forearm. Ulnar nerve, we can feel the first point. You can feel it. Behind the medial epicondyle, we can feel the ulnar nerve. It is over the epiphysis or metaphysis or diaphysis. If you can answer it, then OBGYN sir's class is successful. It is on diaphysis. You know the ossification? Then you can ossification of the humerus. So here we can draw the nerve just behind the medial epicondyle. We can put 1 point. Now we will fill the pisiform cone. Just put a bit lateral to the pisiform cone. And another point, some teachers can still expect that he will give the third point. Third point is this is the medial epicondyle and this is a PPC mode. Join these two lines and make upper 1/3 and lower 2/3. And put a point at the upper 1/3 and lower 2/3. Now you can join these three.
আমাদের কাছে অরণ্য বলে কেউ আছে?
অরণ্য সম্বন্ধী